Okay, so solids, liquids and gases. Solids, here's pretty simple. There's a solid right there. Chunk of wood. Something you notice about solids right away, nothing surprising, they keep their shape, right? All solids, doesn't matter what it is, you know, whether it's, again, one of these weights or something, they keep their shape, okay? They have a definite shape. They also have a definite volume. The volume doesn't change. I can switch on it, squish it, and so on, and it really doesn't change. Oh, sure, a piece of wood, we could bash it apart and so on, but solids, the molecules or the atoms are so close together, they can't get past each other. They're tucked right in there. They really don't get any smaller. They hold their shape because they're locked into position, and you can't squish them down anymore. So, definite shape and a definite volume. So how do we measure volume in a solid? Well, if it's a regular solid like this, we can take its length times its width times its height. Length times width times height. Multiply those together. But what if we have really weird solids? Let's say you had to find the volume of these stones, these little pebbles that are right here. That's not as easy. Watch what I do. Here's a cool thing. Here's a little graduated cylinder. I'll push it up close here. I'm hoping you can see it still. You're going to see that the liquid that I put in here is just water with food coloring. It measures 10 milliliters, which is the same as 10 cubic centimeters. If I want to know the volume of all these little stones, I'm going to put them in the water and watch what happens. It's reading 10. You gotta be kidding me, so I dropped some stones on the ground. Okay, forget those. The volume of the stones that I did get into here, this is now moved up to, well, 15. That means those little stones are pebbles. You take the difference. It went from 10 to 15. 5 milliliters or 5 cubic centimeters would be the volume of those stones. So even though they're weirdly shaped, we can still find the volume of them. Okay. Let's talk about liquids. Here's a liquid, lovely green water. And this one, two things about liquids. Definite volume, but no definite shape. Okay, the volume on this guy, 200 milliliters. Its shape right now is sort of like a cylinder. It's round and standing tall. If I put it in here, again, not surprising, but the shape changed. You know, the liquid now is wide at the bottom and it's narrow at the top. A liquid's going to take the shape of whatever container you put it in. So what's going on? The solids, those atoms and molecules were so tight together they couldn't move past one another. The liquid's not so tight. They can flow and move around one another. They flow. So they will move past each other and take on the shape of whatever you put them into. There's yet another shape. Oh, and notice the volume again. 200 milliliters. We can change the shape again, put it in here, blah, 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 blah. There you go. Here's another shape. That one's almost like round like a basketball or something. This one doesn't have a scale, but I bet you can imagine it's going to be 200 milliliters again. So, no definite shape to it, but it does have a definite volume. Let's put it back in here. Let's illustrate that. I'm going to take this syringe. You've probably played around with some of these before, because they're kind of fun to spray each other with. Okay, so if I put a liquid in here, and I plug the end of this thing, and I try to squeeze this thing, I can't get this plunger to move. Liquids are not compressible. They have a definite volume. You can't smush them down, okay? Because those, again, atoms and molecules, they're close together to where they can just flow past each other, but you can't squish them any closer together. They will have a definite volume. Again, if I plug it up, I can't push that thing down. Definite volume. Let's go to gases. Kind of hard to show you gases when you can't see them. At least the gases we have right here. Some gases you can see because they do have a color to them. But the gas you're most familiar with, air. This is like 80% nitrogen, close to 20% oxygen, and then the rest of it is all trace elements, including carbon dioxide and other things that are in the air. But if we go with a gas, those atoms and molecules are spaced even further apart to where, again, no definite shape. They flow. Oh, you know air flows in and out all around things, right? But they also have no definite volume. If you put a gas into an enclosure, it's going to expand out to fill that space. It's going to space itself out and just fill the place. Kind of like if somebody walks into the room, they have a lot of cologne or a lot of perfume on. If they walk in next to me, I'm going to smell them first, but then eventually that's going to spread out through the room. It's going to spread out completely through the room. But let's take a look at this. Right here. This is a different syringe. On this one, I melted the tip closed. Okay, so nothing can come out of it. So this guy right here, I can pull it out the bag still, and if I put the plunger in, we've got about 50 milliliters worth of air in here right now. But look at this. Oh, I can squish it. Oh, look at that. Oh, anyhow, I just changed the volume of that air that's in there. No definite volume on this one. I let go of it, and it goes back to where it began. Slowly it's moving back to where the 50 is. So, gases, no definite shape, no definite volume. That's the difference. Solids, definite shape, definite volume. Liquids, no definite shape, but definite volume still. Gases, shape and volume are not definite either way. Okay, there's something to think about. This is Mr. Rudder. Do well on your DOL.